Welcome to the channel. Strand 9, question number 5, part B. Find the coordinates of the turning points. In part A, we differentiated a function to find dy over dx, and our dy over dx was x squared minus 6x plus 5. X squared minus 6x plus 5. That was our dy over dx in the previous question in part A. So in part B, it is saying find the turning points. To find the turning points, we solve dy over dx is equal to 0. Now in the question paper, this sentence was not written. I have written the sentence over here to find the turning points, solve dy over dx equal to 0, but that clue was not given in the question paper. So you as a good math student should be able to know that if you equate the differentiated function equal to 0 and solve it, you would be able to lead yourself to get the turning points. So dy over dx is equal to 0. Solve that. There's two ways to solve it now. Either factorize and solve or use the quadratic formula. If we are using the quadratic formula, the value of a is equal to 1 because the coefficient of x squared is 1 over here. The value of b is negative 6. The value of b is equal to negative 6 and the value of c is equal to 5. C is equal to 5. Using the values a, b and c, use the quadratic formula to solve. I'm going to have a go at factorizing and then solving. So factors of 5 are 5 and 1. Factors of x squared is x and x. Now, one of them has to be negative, or both of them has to be negative, so that we get to negative 6. If one is negative, we get a negative over here, but it's a positive. So negative 5, negative 1. That's how you adjust the plus and the minus sign with the numbers, because them two should add up to give you negative 6. Negative 5 plus negative 1 gives you negative 6, the middle term. Now we're going to group them. So we get x minus 5 into x minus 1 is equal to 0. So from here, either the first group, x minus 5 is equal to 0, or the second group, x minus 1 is equal to 0. We get two x values. So your first x value is 0 plus 5. Minus 5 comes this side, becomes plus 5. So your first x value is equal to 5. And then your second x value, x2, is equal to 0 plus 1. The second x value is equal to 1. Do not stop over here. There's more to be done. We need to find the turning points. We just have found the x values of the turning points. Now find the corresponding y values of the turning points. So we have to substitute these x values into the original formula. In part A, our original equation was y is equal to 1/3 x to the power of 3 minus 3x squared plus 5x. So the x values we have found, one at a time we are going to substitute in the original formula to find the corresponding y values for the turning points. We are finding the turning points. So let's start with x1, 5. Put 5 in place of x. So your corresponding y1 will be equal to 5 to the power of 3 divided by 3 minus 3 times 5 squared plus 5 multiplied by 5. So your y1 is going to be equal to, so here use a calculator and we get negative 8 and 1/3. And then let's find the corresponding y2 value. So your y2 will be equal to, put x2 in place of x in the original equation. So 1 to the power of 3 over 3 minus 3 times 1 squared plus 5 multiplied by 1. So that is equal to 1/3 minus 3 plus 5. So let's use a calculator and see what we get for the y2. So using the calculator, we get the y2 value to be equal to 2 and 1/3, positive 2 and 1/3. Do not leave your answer like that. Make sure your answer is presentable. The question was asking us about turning points. So our answer is Our answer is the turning points are at x1, y1, so 5 and negative 8 and 1/3, and x2, y2, so x2 is at 1 and y2 is at 2 and 1/3. So that's your answers. Those two answers in any order, either the second one first or the first one first over here. 5 and negative 8 and 1/3, 1 and 2 and 1/3. Those are the turning points that we were after in this question. Worth 3 marks. So you have to show step-by-step walking very neatly, so that even if your final answer is wrong, you can be awarded some marks, partial marks for correct walking out. Thanks for watching.